I'm recording, eh?
What I'm trying to say is that the speed of the coil.
So, speed. Angular velocity has to be uniform, but the speed. The magnitude of the. Rachel, are you there?
Yes, please.
Induced current. One, you see, as I said earlier, this has to be rotating. If it doesn't rotate, no current will be induced. That is why for continuous current, I said Akosomo, we need to have something which would always be turning the coil. Hence, the energy of the running water is stopped. So the speed of rotation of the coil the speed of rotation of the coil, which we call as the armature. So that is why we need to get something we can rotate the coil fast. In the turbines used in generator, whether hydro or the generators we use at home, the frequency of rotation is that it must rotate 50 to 60 times within a second. In a second, the armature has to rotate 50 to 60 times in a second. And I'm sure you could imagine something rotating something, okay, 50, 60 times within 1 second. You and I cannot do it. So we need to get something which is stronger enough to be doing this. 2 factors that affect the magnitude of the induced current. What do you think? Na, Deborah, Inshira, Rachel.
Mr. Dia, please, can the strength of the field magnets be included?
Exactly. So the strength of the field magnet or magnetic field strength. The magnetic field strength is similar to, I think we discussed this under electromagnetism. So that the strength, the magnetic field strength B. Yes. The third factor. The third factor is the number of coils. The number of coils. The number of coils of the armature. So these are the 3 main factors that affect the magnitude of the induced current for alternating current. Okay, so these are the features of AC. Let's look at advantages AC has over DC. Advantages: alternating current has over direct current. Let's discuss. Deborah, share one with us. What are some of the advantages of AC? The AC has over DC.
Mr. Dia, please. I think the fact that it can flow in different directions. So in that case, I think you can kind of manipulate it than the direct current.
Manipulate what? The AC. And what do you mean by you can manipulate for what? Okay, think through. Gerard, AC over DC. Advantages. What are some of the advantages alternating current has over direct current?
It's easier to produce AC than DC.
Why?
Please, to produce a direct current, you need to get a concentrated acid or concentrated electrolyte and an electrode, but which sometimes it's hard to get. But for the magnets, it's easier to produce because for the AC, it's easier to produce because you can easily get a core of magnets and then put them in and rotate it with a constant angular velocity in a magnetic field.
So production of AC is cheaper. It's true. That's the first advantage. Production of AC is cheaper than production of DC. So look at building. Do you know that the lights we have in our homes can be powered by a voltage of 210 to 240? Okay. Now, the AC can easily produce these voltages. But look at a DC with a voltage of 240. Very, very big. Meaning you have to, develop a very big battery to produce that magnitude of EMF. Look at the car batteries we use in cars. Most of them would produce a maximum voltage of 12. To power bulbs, most bulbs in our homes, you need voltage of 240. So it means you need to assemble over 20 bulbs or batteries to even power TV in our homes. Okay. So production of AC is actually cheaper than production of DC. That's the first advantage. Second advantage, too. Now, Rachel, you are there. Speak.
Mr. Asia.
Mr. Rachel.
So, Mr. Asia, I think the AC can be like transmitted over a longer distance.
Yes. AC can be transmitted over longer distances with a little minimal losses. The losses incurred wouldn't be much. So AC can be transmitted over long distance. That is why Akosombo, which produces AC can be sent all the way from Akosombo to Accra to Cape Coast, okay, for usage. So alternating current can be transmitted over long distances with minimal loss. The losses to be incurred is small. And then the cost is also less in transporting alternating current. So here we are looking at transported over long distances with minimal loss of energy. Okay, and then the cost involved in transporting AC is also less than DC. So I think I've given you 2 in 1. Transported over long distances with minimal losses or loss, and then the cost involved in transporting AC is cheaper than the cost involved in transporting direct current. Do we have more advantages? Ishra, how many advantages do you have?
Please, 2.
Hey, we've discussed more than 2. I think we have so far discussed about 3 advantages. One is cheaper. It's cheaper to produce AC than DC. Then Rachel also said that it can be transported over long distances with minimal losses. Then I also added the cost involved in this transportation. Transporting AC is cheaper than transporting DC.
So it's not only cheaper in transporting it, it's also cheaper in producing it.
Yes.
Okay, then I have 3.
What is the 4th advantage? AC has over DC. Nah, Deborah, you're also there. Think through. Hey, Gerard.
Sir.
Advantages. All right. The last advantage is this, and that is very, very, very important. Alternating currents or voltages, it is adjustable. It is adjustable. What do I mean by it's being adjustable? You have read voltage adjustments, meaning we can either step it down or step it up. We can step AC down or step it up. That is the voltage adjustment thing I'm talking about. What do I mean by step down and step up? To step down means to reduce the voltage. To step up means to increase the voltage. And this voltage adjustment are done by transformers. So transformers are devices that are used for voltage adjustments. step up and step down. So we have step up transformers and step down transformers. Now, what did I say?
You said another advantage is that alternating current is adjustable. That is, they could be stepped down or stepped up by transformers.
Good. So if we are stepping up alternating voltage, what does it mean? Now,
If you are stepping up alternating current, it means you are increasing the voltage.
so I'm stepping up alternating voltage. We are increasing it. Okay. And this is done by transformers. So you see, when Akosombo produces electricity or power, okay, it is the power that is transported. The power is transported. Now, at the point where they transport it, it is around and then it's channeled through the cables, those grid lines, that metallic lines, okay, you see around, on which there are wires for distribution. The magnitude of voltage, okay, and those lines are actually lines that come from the generation or the generating point. Electricity is about three aspects: generation, transmission, and distribution. The generation is done by VRA. VRA, that's the generation. Dam also is part of generation. So VRA manages this generating points. Okay. Now, then, when it is generated, it is also transported by GridCo. So if you've heard of GridCo is responsible for the transmission of power. So VRA produces it and it is transmitted by GridCo. Then ECG retails it. Omaton. They are quite somebody manufacturing palm oil. That I bringing it to ECG to be retailing. So ECG is the retailers of power. They retail and then I sort of manages or services the lines. So it is done by these three: production, transmission, and distribution. Are we okay? So whenever it is produced by VRA, the voltage involved and then transmitted by GridCo on the transmission line, those metallic pylons you see within the community, the voltage up there is around 33 kV. And this is 33,000 volts. Very, very, very high. Then it is fed to the substations within the community. Those areas where you see a lot of transformers, they are the substations being manned by VRA. Then from the substations, it is given to transformers. The transformers you see within our community, that's a stepping up and stepping down. So the transformer also stepped this voltage down to 11 kV. So by the time it gets to the transformers within the community, the voltage has been stepped down to 11 kV, which is 11,000. So the transformers do the distribution depending on the amount you want. So if you are a company and you have the load or the machinery you have at your end are so much heavy duty, then they give you voltage that corresponds to your consumption level. So these they distribute. For domestic usage, as in powering of bulbs, TV, and fridges and all that, the transformer must further step it down to 210 to 240 volts. So the voltage we use in our homes, okay, is within this range. So that is how it works. Okay. Now AC is such that, oh, maybe this one is so much for me. The device I use at home would only require small voltage. Then you must buy a step down transformer. Okay. So the step down transformer would adjust this voltage to the amount that can be used by your device. So AC is the only kind of current that can be adjusted, step down or step up, depending on what you need. Please, any question?
No, please.
So these are the advantages of AC over DC. Okay, DC can actually also be transported over long distance, but you need to use cables with a very large cross-sectional area, because for DC you cannot do this voltage adjustment. So if you are transmitting higher voltage, then you must buy a cable whose cross-sectional area is larger. That is why the wires that are used to transmit 33 kV are larger than what we use at homes. Okay, the larger the voltage, the larger must be the cable size. So for DC, because you can't do these voltage adjustments, if you want to transmit it or transport it over long distance, then you must do so with a very large cable size. So it will bring about cost. Inshira, are you okay?
Yes, please.
Deborah, are you fine?
Yes, please.
Gerard. Gerard. And I'll call you when you are garage. Gerard. Oko garage. Okay. So that's it. So these are the advantages AC has over DC. Rachel, are you okay with the AC generator?
Yes, please.
We'll look at it.
I'm not okay with that one.
With this one.
Yeah.
So this is the simple design or architecture of the generator you use in your homes. Generator at Akosombo. as Professor Deborah said, for AC to be produced,
Yeah.
a coil. Yeah, hello.
Mr. Dia, please. You see, sometimes they say the transformer has blown or something like that. Is it because maybe the voltage coming is higher than it can adjust?
No, you see, before it is mounted within the community, we look at the need of the community, the total power they will need. So it's not as if the voltage given to it is greater than it requires, because they will calculate to know what the amount of voltage they need to connect to a transformer. Okay, but this it has blown 10 is as a result of we have short circuit when it rains and the wires touch. Okay, it drops, short circuiting drops the resistance. It drops the resistance. So when the resistance is so low, meaning large amount of current will just flow through and it is dangerous, blow the fuses and affect the transformer. Okay, then when lightning strikes, hits the transformer as a result of fault, even though there are interventions, okay, remedial interventions, but you cannot be 100% with your protection. Lightning can affect it. And so these are factors which blows the transformer, but not that whatever was given to is greater than it could take. Are you okay?
Yes, please.
Okay. Any more questions? Gerard?
Sir.
Any question?
Oh, no, sir.
All right. Now, don't you have a question? Rachel?
No,
Mr. Adrian,
sir.
no.
All right. Then let's look at AC. Alternating current changes direction. Changes directional flow. So it flows in the positive, it flows along in the negative. But listen, when you see devices that are powered by AC, unlike batteries where you have positive and then negative always being indicated. And for batteries, whenever you are connecting and you don't follow for yes, batteries and then DC sources, whenever you are connecting an appliance and you don't follow this direction, either it will not work or you harm the device. So you must always connect gadgets to, you must follow the positive and then the negative. So for sources that produce DC, there is always an indication of the positive terminal and then the negative terminal. If you look at all other sources that produces AC, there is no positive, there is no negative. And last time I explained to you. So DC sources are usually represented by the cell, where the longer line represents positive, the shorter ones represent the negative terminal. For AC, we don't show anything like that. So the moment you see this, then the source is DC. AC in a circuit is represented by this and then a sine function. So this is what will tell you that this source is AC. This source is AC. Now, there's no indication of positive. There's no indication of negative. The reason is that current flows from positive terminal, a point of a higher potential, to a point of a lower potential. But today, this is positive, higher potential. This is okay. By two directional flow, at another time, this can be positive and this will be negative. Because of the changing direction, the polarity or the terminals also changes. So you can't indicate any of them to be positive or negative, because at a given time is positive, at another time is negative, and it does changes every time, okay, because of the changing directional flow. So within the circuit, if this is a circuit, it means it can flow in this manner. Okay, then it can also flow in this manner. So if you have a system like this, can you indicate any size to be positive and negative? Can you?
No,
And
please.
yes, you can't do so because the condition isn't permanent. The condition over here isn't permanent. It can change.
Mr. D.
Mr. Deborah.
So, Japanese, my network went off, so I didn't see what you just said.
Oh, it hasn't been cleaned. It's still on the board though. Is it the explanation?
Yes, please.
Right, Ishra. Nana Ishra. Ishra, you there? Rachel. Hello, Rachel.
Mr. Asia,
Explain what I said to Deborah for me. In
okay, Mr.
connection-
Asia, you are saying that for the AC, can we distinguish which one is the positive and the negative, positive, negative, and they can also flow from the negative to the plus. It doesn't have a particular direction. And you use a diagram on the board to explain.
So it flows in two
And he
different
asked that
directions.
and yes, please.
Deborah, are you okay?
Yes.
Oh, it's your line. I troubling us. I can't hear from Deborah. I can't hear from Ishra. Are you there?
Yes, please.
Ishra, are you there? Okay. All right. Now AC. AC is harmonic. It's a harmonic function. If you recall, when we were looking at examples of simple harmonic motion, I told you that the motion of current in a conductor is an example of simple harmonic motion. And this refers to alternating current, AC, not DC. So the motion of current in a conductor is an example of simple harmonic motion. That example applies to alternating current, not direct current. So anything which is harmonic has a sign, is represented by a sign function. The reason for which we represent AC by a sinusoidal shape. So alternating systems, which includes alternating voltage, okay, when we talk of alternating systems, here we refer to alternating current and alternating voltage. Current and alternating voltage. So for alternating systems, we are referring to this. Okay. This, so because it's the motion of current in a conductor, a simple harmonic, we represent alternating voltage and current by a sign function, sinusoidal. Any harmonic function mathematically is represented by the equation, is represented by the displacement equation of a body executing simple harmonic motion, where y is equal to a sine omega t, or a sine omega plus or minus phi. Because of this, and the fact that alternating current is a harmonic function, AC, alternating current, is represented mathematically as this. I is equal to, that is the amplitude. For current, we have I naught or I maximum sine omega t. So alternating current mathematically is represented by this. I is equal to I naught or Im or Ip sine omega t. And this is because it's a harmonic function. It's like this. And every harmonic function is represented by this. Alternating voltage is also represented by V is equal to Vm sine omega t. So this is alternating current. This is alternating voltage. Rachel.
What does the small m stand for the I?
I'll also ask you a question to answer. For the displacement equation of a body executing simple harmonic motion, A sine omega t, what does the A represent?
The amplitude.
So this, the amplitude or
The maximum displacement.
Maximum displacement. This is also the maximum current.
Okay.
This is the maximum voltage. So where we call I, okay, this is the displacement within that time. Don't forget, this is, Let me do it with omega t. So when you find y, what have you obtained? When you find y, what have you obtained?
You obtain the displacement.
Within
Time t.
a given time t. So you found a displacement within that instant. Okay. Because of this I is also known as instantaneous current. Instantaneous current, meaning current within that time or instant. Gerard, are you okay?
Yes, sir. Yes, sir.
Inshra, are you there? Hello, Inshra. Oh. Inshra is getting me annoyed. And now you are quiet.
She's not on the call.
Now you are also quiet.
Mr. Edia, please, I'm here.
Now it's making me annoyed. She don't ask questions.
Mr. Edia, please. I don't have any question.
Okay. Then you are making me annoyed. So I is the current within that time, instant. That's why I asked, what does this y mean? Y means the displacement within that given time t. So the current within that time t, hence instantaneous current. Im, and this is often represented as Im. You can see in other books IP. When it's P, it means peak. Or you can also see I naught. It simply means maximum current. So maximum displacement. So graphically, it's like this. A. Okay, for current, it's also like this. When you draw the sine function, this is the maximum current, and this other side is also the minus of it. If it's about alternating voltage, then this is the maximum or peak voltage. This is the maximum or the peak voltage. We call this, how would you call this? How would you call this?
The instantaneous voltage.
Instantaneous voltage. The voltage within a given time t. Is that okay? Colleagues, in fact, I'll have a class in the evening, but it's on condition that there is power. So I went to school to teach. Let me rest, and then if there is power, continue in the evening for you. Okay. Okay.
Yes, please.
Yes, please.
Because I feel tired. So you let me rest, charge my phone, and see what to do in the evening. Now, are you okay?
Yes, please, Mr. Edia.
So I can rest before time. All right. On this note, Gerard, is your hand up?
Oh, no, sir. So just
Okay. All right. So I'll see you in the evening. But it's on condition that there's power. So all right.
You're
So see
welcome.
you. Oh, it will certainly be 7 to 9.
Okay.
All right.
Mr. Age, will it be a continuation of it?
Pardon?
Will it be a continuation of it?
Yes. It will be a continuation. All right. Bye-bye.
Bye.